Good afternoon, class. Sorry, I just wanted to provide a quick recording that you can also use to help you study for your mid-unit exam tomorrow. So here's the review that we completed in class. Our GMAT was very simple. It was to complete or list the different trophic levels. We have discussed trophic levels almost every single day in class. I just wanted to make sure to name them. So we always start off with our first trophic level, which is our producers. Our producers are plants, algae, phytoplankton, anything that makes their own food, and they have the largest energy and largest biomass. Then we have our primary consumers. So primary, if you know Spanish, would be like primero. Secondary, like second or segundo, secondary consumer. Due to space, I'm going to do those little arrows. It just means same as. Then we have tertiary, like three or tercero. Then we have quaternary. This one's more related to Spanish, like cuatro. And then lastly, we have our decomposers. So those are the main trophic levels that we talk about. They might sometimes mention it as trophic levels, which trophic level is the grasshopper on, the hawk in. So just know whenever they mention trophic levels, they're talking about producers, primary consumers, secondary, tertiary, quaternary, and decomposers, and so forth. So here we can begin. Autotrophs are anything that, organism that makes their own food. I'll also be posting this as a PDF, so you'll be able to see it. So the main source of energy, our organisms that make their own food are our plants when we're talking about a terrestrial ecosystem. So that's our plants, our trees, our grass, and so forth. When we are talking about, when we are talking about an aquatic ecosystem, that's our algae or seaweed or phytoplankton, all of those organisms make their own food. Normally the process that they use is photosynthesis, so the main source of energy is the sun. The explanation would just simply be that sunlight is needed for photosynthesis. So for this one, I want to make sure that you identify that this is energy, the main source of energy. Now we're going to talk about the main source of matter. The main source of matter is a little bit different. The main source of matter is carbon dioxide, which we use in our carbon cycle. So carbon dioxide would be CO2. And the explanation for that is the process of photosynthesis. Normally, we would have learned about photosynthesis, but since they moved the units around, what you need to know is that the plants intake carbon dioxide. So whenever the plants are using the process of photosynthesis, they absorb carbon dioxide. So photosynthesis reduces the carbon dioxide in the atmosphere. So that's the process. So basically you have carbon dioxide, you use it and you produce sugar, which is the food for plants, and oxygen. That's why we love the process of photosynthesis, right? It gives us oxygen, which we use to breathe. The next thing that we have are heterotrophs. So heterotrophs are organisms that consume, so they eat, they consume producers or other consumers. We have different levels of consumers, so organisms consume producers or other consumers. A very easy way for you to identify a heterotroph in a food chain or food web is if you have an arrow pointing towards it. If there's an arrow pointing towards your organism, that means that it's eating that food. Right now, you'll notice when we look at a food web, there's not any arrows pointing towards our producers because they do not eat anything. They just use the energy of the sun. But any type of consumer is going to have an arrow pointing towards it, any heterotroph, because they are consuming either a producer or other consumers. So you can pause the video right here so you can answer the next two questions. List the autotrophs from the energy pyramid above. So these two questions would be answered using this pyramid. You can try it on your own, and right now I'll share the answer. So autotrophs, we just defined this right now. Autotrophs in an energy pyramid are just organisms that make their own food. So there's only one autotroph in this pyramid, and that would be the grass. Heterotrophs are everything else. So that would be the grasshopper, GH for short, the frog, and the hawk at the very top. So those are our autotrophs and our heterotrophs. Again, when I'm asking you about the trophic levels, we would have our producers, our primary consumers, secondary consumers, and tertiary consumers. So those are our trophic levels in that specific pyramid. We're moving on to the 10% rule. So the 10% rule states only 10% of energy transfers up trophic levels. That beautiful singing that you hear in the background is my 2-year-old Joaquin. So only 10% of energy transfers up. Everything else is lost as heat. So heat can be thought of as kinetic energy. So energy of movement, digestion, of obtaining that food, all of that is how the energy is lost as heat, and 90% is lost. So here, looking at this example, our producers always have the greatest amount of energy. They start off as 100. The method that I like to use is to move the decimal. So we would move the decimal forward. This one becomes 10. The next one becomes 1%. This is my very bad percentage sign. And then lastly, we have 0.1%. That method can be used with any number at all, and you'll be able to correctly answer your question on the 10% rule. So in the pyramid above, again, we're still using the same pyramid. It is the clearest one that printed on your paper. The grasshopper has 500 kilojoules of energy. What energy would the following have? So I know my grasshopper has 500 kilojoules. And from there, we can set up our question to answer the rest. So the grass is the producer. It is a trophic level below it. So instead of moving our decimal forward, we're actually going to work a little bit backwards and move our decimal back. So our grass would have 5,000 kilojoules of energy. You can check your work by simply just moving your decimal forward, and you get the answer 500. So that means your process is being done correctly. So at 500, we're going to move our decimal forward, and here we get 50 kilojoules for the frog. So our frog would have 50 kilojoules of energy. And lastly, if I move my decimal forward one more time, my hawk will only have 5 kilojoules of energy. So again, use the process of moving the decimal. We go this if we're going upwards. We go to the left, and if we're going downwards, you have to add or make the number larger. This is downwards. So this is when we're trying to get a larger number or go to a trophic level below the one we are currently working with. This next question, so it is a little bit more complex. So basically, you are going to first list your trophic levels on the pyramid. After that, we're going to go through every single food chain, and then we're going to place them at the highest level. So if I have one that's a primary consumer, secondary consumer, and tertiary consumer, I would list them only in the tertiary consumer. The question that you have like this is multiple choice, so it makes it a lot easier. I think using the open-ended question made it a little bit more difficult, but we like a challenge, right? So the first thing I like to do is label. So I want us to label first our pyramid. It is going to save you a headache later, I promise. So here we know our producer is this berry bush or berry plant. So this would be a primary consumer, secondary consumer. That is one food chain. Here I have a producer. I would have a primary consumer and a secondary consumer. Here I have a producer, primary consumer, secondary consumer, because it went straight to the eagle. Here we have a primary consumer. This would be a secondary consumer, and this would be a tertiary consumer. So our eagle, the highest consumer rating it has so far is tertiary. And I go from the berries to the caterpillars, which would be I'm running out of colors, which would be a primary consumer. And then the bird would now be a secondary consumer, the snake would be a tertiary consumer, and the eagle would be a quaternary consumer. We can follow the same process, so producer, primary consumer, secondary consumer. Now the fox is considered a tertiary consumer, so that's the highest it is listed. I'm going to use purple again just because I'm limited on colors. So producer, primary consumer, secondary consumer. It already has tertiary consumer and quaternary, secondary consumer, tertiary. We already have that. Lastly, let me see if I can get a different color. Let's work with the berry bush, primary consumer. So this would be our primary consumer, secondary consumer. It already has tertiary consumer. It looks pretty much done, class. So from here, we can list it. So our producer, of course, would be our berry plant. That is the only producer we have in this food web. Our primary consumers, which one stayed with primary consumer as their highest? So it would be the butterfly. It would be the caterpillar. And it would be the squirrel. Next, we have our secondary consumer. So the ones that ended up with secondary consumer as their greatest trophic level was the frog and the bird. The next ones that ended up with tertiary as their highest consumer level is the snake and the fox. And we only had one quaternary consumer, and that was our eagle. So again, just make sure that you take your time, read the questions, and try to understand what they're asking. The quiz or the mini unit exam is only 11 questions. 10 of them are multiple choice. And the last question has 2 parts. There's 4 different answers. And that one is going to be your open-ended question, which is about 30 to 40% of your grade of the whole exam. So we need to make sure to complete it. So here's what we have so far, class. Again, I'll be posting this. Next, this is our last part, interpreting graphs. So when we are interpreting graphs, we always need to look at our x-axis, which is horizontal. Our y-axis was this vertical, and very important to pay close attention to our legend. So anything that they give you there, this is considered your legend. So looking at this, we know that we're looking at the height over time, and we're dealing with water with minerals, tap water, and alkaline water. So as we stated before, when we are looking at graphs, they're telling us a story. So what is this graph showing me? It's showing me that at different waters, different types of water, there's a growth change, right? So effects of water on growth. Again, when you see a question like this on your exam, it'll use the process of elimination, so it's a little bit easier. But again, look at your x-axis, look at your y-axis, and make sure to look at that legend. A lot of information is provided there. So again, what 2 variables from x and y? The time of growth to the height. So growth over time. It's showing us the growth over time. A control group. So when you're looking at a control group, you are wanting to see the group that is unchanged or closest to normal. So my best example is in science fair, a lot of science fair that I've judged, I normally see an experiment with plants and the effects of music has on their growth. So students normally have a control group, which is a plant growing without any music. Then your dependent variable or your changing variable is the type of music. So one plant will have classical, another plant will have pop, and then another plant will have metal or rock, right? So those are variables that you can change. Your control would be the plant without music. So that's what you're comparing it to, right? So here, our control is just regular water. We are trying to see if water with minerals or alkaline water is going to help it grow more. So what do our results show us? If we look at our graph here, we can see that this grew the largest. So water with minerals grows most. And the one that grew least or was negatively affected was that diamond one. So alkaline water had a little bit of a negative effect. So again, you'll have something similar. You will be interpreting graphs for the remainder of the year, and just make sure that you are comfortable with looking at graphs. Make sure you look at the X and Y axis. Again, using multiple choice will make your questions a little bit easier. So almost there, guys. This last part is simply going over phase 1 and phase 2 of a growth graph. So remember the example that I provided that we had. It was about how the park by my house, they introduced ducks, and when they first introduced ducks, they multiplied very quickly. So this is what you see here. The population size is increasing very, very fast. So this is called exponential growth. So that is what's happening in phase 8, exponential growth. This normally occurs when a species is introduced to a new area. Next, we have phase B. So phase B is called carrying capacity. So there comes a time where our environment only has a certain amount of resources that it can use to sustain the population. So a perfect example is our classroom. My classroom cannot hold 100 students. I do not have enough space. I do not have enough chairs. So that is an overpopulation. That is way over my carrying capacity. We are comfortable at the amount of students that we have so far. So carrying capacity. So phase B is carrying capacity. Normally, when you see words like this, in order for you to get the full credit, make sure that you define them. So carrying capacity is the population, environment, I misspelled it, I'm sorry, can support with given resources. So there is only a certain amount that the environment can hold, right? It only has X amount of resources, so we can't have 20 million, ducks in my park because the park does not have enough space, food, grass, anything like that. So that's when you see the carry capacity. I'm sure you can see that it goes up and down. So reasons that it can go up and down, reasons that it's increasing and slowly decreasing. One is predation. So we have predation. That is when when the predators eat the prey. So sometimes we have a lot of prey. So the predators eat all the prey, and then we have less prey, and then our predators go down. So that's similar to what we've seen in a predator-prey graph. Another reason might be disease. So disease might spread in the population because they're overcrowded and it spreads easier. So that's going to decrease the amount of the population. There's some things that are out of their control, like climate and weather. Like unfortunately, we've seen over the weekend a terrible hurricane has hit the people of Louisiana. So their ecosystems are going to be drastically changed. The animals had no control over that hurricane hitting their area. So that would be an effect on their whole environment. And lastly, it can also be availability of resources. So that's about it, class. Make sure to study your notes, study your notebook, and you should be good for the exam tomorrow. I wish you the best of luck, and I'll see you tomorrow for your exam. Bye, class.